Okay guys, this is the second part of similar shapes where we're going to start to involve areas and volumes, okay? Um, it's probably best to watch my first video about similar shapes with only linear scale factors, and once you get the gist of that, probably come to this video here. So let's start with a quick example. So let me introduce you to this topic. Let's say we have two rectangles and they're similar. We think back to what similar shapes are. Similar shapes are what? One shape is an enlargement of the other. Yep. There's a small rectangle and there's a big rectangle. It's two. All their angles, all corresponding angles must be the same. So, for example, this is a right angle, and this is a right angle. This is a right angle, this is a right angle. So their angles are the same. And the third fact about similar shapes, very important, is all corresponding sides have the same scale factor. So I know that this side corresponds to this side. And 8 is 2 times bigger than 4, so our scale factor is times by 4. 8 is 2 times bigger than 4, so our scale factor is times by 2. Okay? So if I had this length here, let's say this length was 3, how would you find this length? Well, you just get our 3 and multiply it by the scale factor, because these corresponding sides must have the same scale factor as the other corresponding sides. So 4 times 2 makes 8, so 3 times 2 makes 6. So the length is 6. Okay? Now, let's say we this rectangle and we found out the area. So to find the area of a rectangle, it's 3 times 4, which is 12. And then a lot of people would assume that if the area of the smaller shape is 12, to find the area of the bigger shape, we must multiply it by 2, because that's our scale factor. So 12 times 2 is 24. But if we were to actually find the area of this rectangle, you'd notice something. To find the area as length times width is 6 times 8, 24. No, it's actually 48. So this brings us to a very important realization, guys. The length scale factor of a shape is going to be always different to the area scale factor of a shape. Because so in this example, the length scale factor was times 2, but let's look at the area scale factor. Well, have a look. It's 12 to 48 is times by 4. Okay? And then let's pretend we're going to make this shape into a rectangular prism, a cuboid. And let's give this side a value. Let's say it's 5. Well, if this side is 5, its corresponding side must be 2 times bigger. So it's going to be times 2, so 5 times 2 is 10. Let's go ahead and find the volume of this shape. So to find the volume of a rectangular prism, it's length times width times height. So 5 times 4 is 20, times 3 is 60. And the volume of this shape, length times width is 80, times 6 is 480. And what's the scale factor of our volumes? 60 to 480. 60 times what is 480? We can just do 480 divided by 60, which is times 8. So the scale factor of the volumes is times by 8. So what do you notice? Are the scale factors all the same or different? They're all different. The length scale factor will be different to the area scale factor, and the area scale factor will be different to the volume scale factor. Okay? So you gotta really keep that in mind, okay? Now, we have to find a link between these three numbers, okay? Well, before we find that link, let's do another example of this. So let's draw a rectangle again. Let's start with a rectangle, a bigger rectangle. Let's say this is a side length of 2 and this is a side length of 6. And these are similar shapes. So let's find our scale factor. From 2 to 6 is times by 3, so our length scale factor is times 3. So if this side was 1, to find this side, you just have to do 1 times our scale factor, which is 1 times 3 is 3. Okay, let's find our area. So this is our length scale factor. To find the area of a rectangle, it's length times width, so it's going to be 2 centimeters squared. And then from 3 to 6, 3 times 6, is 18. The area of this rectangle is 18 centimeters squared. All right, and then let's have a look. From 2 to 18, what's the scale factor of the areas? 2 times 9 is 18, so the area scale factor is times 9. And then let's turn this rectangle into a rectangular prism. Let's say this is 10, okay? So this length is 10. This length must be 3 times bigger, so 10 times 3 is 30. Let's find the volume. So 10 times 2 times 1 is 20, so the volume is 20 cm cubed. And the volume here is 30 times 6 is 180. 180 times 3 is 540. So these are the two volumes. What's the scale factor of the volumes? It's not times 3. It's not times 9. 20 times what is 540? Well, we can do 540 divided by 20, which is going to be 27. Okay, so now it's time to start looking at connections between the length, area, and volume scale factors 2, 4, and 8, and 3, 9, and 27. And hopefully, you'll see something. Let's get our scale factors from that last one. Well, what you should see, guys, is if the length scale factor is times 2, the area scale factor is basically the length scale factor, which is times 2, squared. 2 squared is 4. And the volume scale factor is basically the length scale factor cubed, because 2 cubed is 8. And it's the same thing here. The area scale factor is basically the length scale factor squared. 3 squared is 9. And the volume scale factor is basically the length scale factor cubed, because 3 cubed is 27. So we can turn this into a little cheat sheet. So the length scale factor, area scale factor, and volume scale factor. Let's say the length scale factor is times by s. So s can be any number. To find the area scale factor, we're going to get the length scale factor, which is s, and we're going to square it. And then to get the volume scale factor, we can get the length scale factor, which is s, and we can cube it. I'm using s here. Sometimes I use r for ratio. Sometimes I use x. You can use whatever letter you want. I'm just going to use s in this case, okay? And that's how you find the scale factor for the area and the volume using the length scale factor, okay? So be careful. The area and the volume scale factor is never the same as the length scale factor. They're all different, okay? Alright guys, let's hop into some questions now. Cylinder A and cylinder B are mathematically similar. The length of cylinder A is 4 and the length of cylinder B is 6. The volume of cylinder A is 80 centimeter cubed. Calculate the volume of cylinder B. So let's just label this quickly that the volume of the shape is 80, and we're trying to find the volume of this shape here. Well, since I see two shapes and it says that they're similar, let's use the idea of scale factors, okay? So I know the two lengths. The length of this is 4, the length of this is 6. So why don't we find a scale factor between the two lengths? So 4 times what makes 6? We'll just do 6 divided by 4, which is 1.5. So our length scale factor is times 1.5. Now, a common mistake people will do now is they'll say, okay, if the scale factor is 1.5, I'll just multiply 80 by 1.5. But you have to remember, guys, the length scale factor is always different from the surface area scale factor, which is always different from the volume scale factor. If the length scale factor is 1.5, we can't just assume the volume scale factor is 1.5. So how do we find out the volume scale factor? Well, remember, guys, if the length scale factor is times s, the area scale factor is times s squared, and the volume scale factor is times s cubed, where s is the scale factor. So if our length scale factor is 1.5, to find the area scale factor, we'll do 1.5 squared, and the volume scale factor will be times 1.5 cubed. And 1.5 cubed is 3.375. So that is our volume scale factor. Now, if the small volume is 80, to find the big volume, we'll just simply multiply by 3.375, and that should give us our volume, 270 centimeter cubed. And that's our answer. Next question. Two solid shapes, A and B, are mathematically similar. The base of shape A is a circle with radius 4. The base of shape B is a circle with radius 8. The surface area of shape A is 80. Work out the surface area of shape B. Okay, so I see two shapes, and it tells us they're similar. So straight away, shapes, they're similar. It's all going to be all about scale factors. So we know both and we know the area of this shape is 80, and we're being asked to find the surface area of shape B. Okay. We know the radius of A is 4 and the radius of B is 8. So why don't we find the length scale factor between A and B? Well, from 4 to 8 we just times by 2. So our length scale factor is times by 2. Now, to find the missing area, we've defined our area scale factor. So if our length scale factor is times 2, remember, guys, the area scale factor will be the length scale factor squared. So basically the area scale factor is times 2 squared. 2 squared is 4. Our area scale factor is times 4. So now we can get our area, and we can multiply it by the area scale factor, which gives us 320. And that is our surface area of shape B. Now we'll do part B. I'll do another color. We'll do it here. The volume of shape B is 600. Find the volume of shape A. So we know the volume is 600. We need to find the volume of shape A. Well, we know the length scale factor is times 2. The area scale factor was times 2 squared, which was times 4. And to find the volume scale factor, we have to get the length scale factor and cube it. 2 cubed is 8, so the volume scale factor is times 8. So, since the volume of the big shape is 600, to get to the volume of the smaller shape, we got to divide by 8. So we'll do 600 divided by 8, which is, oh man, I'm not in it today, 75. And that's going to be the volume of the smaller shape. So same as before, guys, we're just using the exact same cheat sheet idea. If the length scale factor is times by s, the area scale factor will be times by s squared, and the volume scale factor is the length scale factor cubed. Question. Two cylinders, P and Q, are mathematically similar. The total surface area of cylinder P is 90 pi. The total surface area of cylinder Q is 810 pi centimeters squared. The length of cylinder P is 4 centimeters. Work out the length of cylinder Q. I got to find out this length here. Okay. So I have two shapes. They're mathematically similar. There's information about the lengths, and there's information about the areas. So we're definitely going to be using scale factors in this question, and that's how I know. Let's first label all our information. I'll do it in black. So the area of cylinder P is 90 pi, and the area of cylinder Q is 810 pi. In order to find this missing length, I need to find the scale factor between 4 and I got to find the scale factor between the two lengths, 4 and our unknown length. But I don't have a length scale factor. But what I do know is I know both of the areas, so perhaps I can find the area scale factor instead. So we think, how do we get from 90 pi to 810 pi? If you want, you can ignore the pi's and just think to yourself, how do I get from 90 to 810? 90 times what makes 810 is 9. I just did 810 divided by 90. So our area scale factor is 9 times 9. Now I got to find the length scale factor because I want to find this missing length. So how do we do this? We have to work backwards a little bit. Let's think back to our cheat sheet. If the length scale factor is times s, our area scale factor is length scale factor squared, and the volume scale factor is the length scale factor cubed. In this question, I know what the area scale factor is. So we can say s squared is equal to 9. And we want to find the length scale factor. So we want to find s. Well, this is pretty straightforward. Something squared makes 9. What makes 9? 3 squared makes 9, so s must be 3. And therefore, if s is 3, s is our length scale factor, so the length scale factor is times by 3. So now, if this length is 4, to find this length, we'll simply multiply by 3, which gives us a length of 12 centimeters. Now, let's look at the second question. The volume of cylinder P is 100 pi centimeter cubed. Work out the volume of cylinder Q. So we know that this volume here is 100 pi, and we want to find this volume here. Well, in order to do this, I need to find the volume scale factor. Well, this is pretty straightforward. Since our length scale factor is times 3, to find the volume scale factor, we always get the length scale factor and we cube it. So times 3, and we're going to cube that. 3 cubed is 27, so our volume scale factor is multiplied by 27. Since we're going from a smaller shape to a bigger shape, we're going to do 100 pi times 27. 100 times 27 is 2,700 pi centimeter cubed. And this is our answer. Zane buys mineral water in large bottles and small bottles. The large bottles are mathematically similar to the small bottles. Large bottles have a height of 32 and a volume of 2,000. Small bottles have a volume of 500. Work out the height of the small bottle and give your answer to 3 significant figures. So our goal is to find out the height of this bottle here. Okay, and I know that these two shapes are similar. So straight away I'm thinking I've got to use scale factors. Well, in order to find x, I need to find the length scale factor. But how do I find this length scale factor? Well, actually, I know both volumes in this question. So why don't we find the volume scale factor? Because we have both volumes. So how do we get from 500 to 2,000? 500 times what is 2,000? I'll just do 2,000 divided by 500, which is 4. We know the volume scale factor is times 4. And now, since we want to find this length, we want to find the length scale factor. So I can apply it to 32 and find out our unknown length. How do we do this? Well, let's think back to our cheat sheet. If the length scale factor is equal to s, our area scale factor is s squared, and the volume scale factor is s cubed. And in this case, we know the volume scale factor. So s cubed is equal to 4. So we can write that down. S cubed is equal to 4. Now, we want to find our length scale factor, so we have to find s. So if s cubed is 4, how do you find s? Well, we can just use our algebra. I want to get rid of this cubed sign. The opposite of cubing is cube root. So we're going to cube root both terms. So cube and cube root cancels out, leaving us just with x. And what's the cube root of 4? Well, let's use our calculator to find it. And since we want our answer to 3 significant figures, whenever I do calculations, I'll always have double the number when I do calculations. So the cube root of 4. Okay, and our calculator is 1.587401. And that is going to be our length scale factor, times by 1.587401. Now, since we're going from the big shape to the small shape, we're going to do 32 divided by 1.587401, which is going to be 20.1587. Now to 3 significant figures, so 1, 2, 3. So we have to round it to the nearest first decimal place, so 20.2. And that is the height of the smaller bottle. So here, since we had both volumes, we could find the volume scale factor, which was times 4. The volume scale factor is also known as s cubed. So we can say s cubed is equal to 4. We want to find the length scale factor, so we want to find s. We have to get rid of this cubed somehow. The opposite of cubing is cube rooting it, so we're going to cube root both sides. The cube and the cube root cancel out. And then the cube root of 4 is 1.587. And since we're going from the big shape to the small shape, we did 32 divided by 1.587401 to get 20.2. Question, we're going to start involving ratios now. The volumes of 2 mathematically similar solids are in the ratio of 8 to 125. The surface area of the smaller solid is 24 centimeters squared. Work out the surface area of the larger solid. All right, so there's 2 similar shapes, but it's not been drawn out for us. All right, so if you want, step 1 is you could draw out 2 similar shapes. It doesn't really matter what they are. Let's just draw out 2 cylinders. That's the first part. Because there's 2 similar shapes, let's visualize the problem. Now, what do we know? The volume of the 2 similar shapes are in the ratio of 8 to 125. So we can just say the volume is 8 parts, or 8 units, or just 8. And the volume of the big shape is 125 units. Okay? It could be centimeters, it could be meters, it could be kilometers. We don't really know, we don't really care. As long as it's 8 units and 125 units. That's what ratios are. So now, and we also know the surface area of the shape is 24 centimeters squared. And we want to find the surface area of this large shape. Well, since I have values for both the volumes, why don't we find the volume scale factor? So how do I get from 8 to 125? Well, I'll just do 125 divided by 8, which is going to be times by 15.625. Now, in order to find this missing surface area, I have to find the surface area scale factor. So I want to find the surface area scale factor. Let's go back to our cheat sheet. So if the length scale factor is s, the surface area scale factor is s squared, and the volume scale factor is s cubed. And in this case, we know the volume scale factor. So we can say, cool, s cubed is equal to 15.625. And I need to find the area scale factor, which is s squared. So that's our goal. We have to find s squared. How do you get from s cubed to s squared? This is pretty tricky. What I recommend in this question is to first find the length scale factor. So to find s. So how do we go from s cubed to s? Well, let's get rid of this cube sign. We have to cube root both sides. Cube and cube root cancel out, leaving us just with s. And the cube root of 15.625 is 2.5. Now, once we have s, to get to s squared, we'll just square 2.5, which is going to be 6.25. So now our surface area scale factor is going to be times by 6.25. And since we're going from a small shape to a big shape, we're going to multiply by 6.25. So 24 times 6.25 is 150. And that is the surface area of the large shape. And guys, before I assign you some practice questions, a frustum is made by removing a small cone from a large cone. The cones are mathematically similar. The large cone has a base radius r and height h. Given that the volume of the frustum over volume of the large cone equals 98 over 125, find an expression in terms of h for the height of the frustum. A lot of information. Let's have a look. Let's read through it step by step. A frustum is made by removing a small cone from a large cone. So there's this large cone. They've removed this small cone, and it's left with this shape here, which is our frustum. So they've drawn it out on the side. The cones are mathematically similar. So this cone and this cone, we can use our scale factors. I see similar shapes. I think to myself, scale factors. The large cone has a base radius of r, great, and height of h, great. Given that the volume of the frustum is over volume of the large cone is 98 over 125, find an expression in terms of h for the height of the frustum. Okay, so where can we start? Well, I'm first looking at this. Actually, we want to find an expression for this height here. That's our goal. So it's not going to be an actual number. It's going to be an expression in terms of h. It could be half h. It could be 1/3 h. That's what it means by expression. Okay. I see they've given us a scale factor in terms of a fraction. What you can do is if you're ever given a scale factor in terms of a fraction, we can turn it into a ratio, just simply as 98 over 100 to 125. So 98 is the frustum volume. So the frustum volume is 98 units, and the large cone volume is 125 units. So if the large cone has a volume of 125 and the frustum has a volume of 98, or I can put it here, we can then find the volume in terms of units of the small cone. So the big cone is 125, the frustum is 98. We can do 125 minus 98 to find the volume of the small cone, which is 27. Okay, that's the first thing we can do. We can find out the volumes for the big cone, the small cone, and the frustum. Now, we want to find an expression in terms of height in terms of h for the height of the frustum. Well, let's just draw out the small cone and the big cone in a 2D format. We know the big cone has a length of r and a height of h. And we know that the small cone has a missing radius and a missing height. We don't know what they are yet. Now, we know the volume of the small cone is 27. So the volume is 27. And we know the volume of the big cone is 125. So since we have both volumes, we can find the volume scale factor. So how do we get from 27 to 125? Let's have a look. It's going to be the volume scale factor is going to be 125 divided by 27 gives us this nasty number, 4.62962963. Yikes. We don't like that number as our scale factor because it looks like it's recurring. So we can write our scale factor as a fraction instead. In order to find a scale factor, we did 125 divided by 27. So let's just leave our scale factor in 125 over 27, because that's how we find it. Now, we want to find an expression for the height, okay? Well, height is referring to the length, so we have to find the length scale factor. Now, let's look at our cheat sheet again. If the length scale factor is s, the area scale factor is s squared, and the volume scale factor is s cubed. Now, we know the volume scale factor, so we can say s cubed is equal to 125 over 27, and we want to find the length scale factor, which is s. Well, how do you get rid of this cube? We're going to cube root both sides. Now, we have to cube root this fraction. If you ever want to cube root a fraction, all you do is you're going to cube root the top value and cube root the bottom value. And we can solve it. So the cube root of 125 is 5, and the cube root of 27 is 3. So we know the length scale factor will be 5 over 3 times 5 over 3. Now, if we know the height is if we know the height is h, to get to the smaller height, we have to divide. So we're going to get our h, and we're going to divide it by our length scale factor, which is 5/3. Now, whenever we're dividing fractions or multiplying fractions and adding fractions or subtracting fractions, if you have one fraction, turn the other value into a fraction. To turn h into a fraction, to turn anything into a fraction is always going to be h over 1. How do we divide fractions? Well, we keep the first fraction the same, we switch the division into a multiplication, and we flip the second fraction, so 3/5. So now we can multiply the numerators, so 3 times h is 3h, and 5 times 1 is 5. So we know the height of the small cone is 3/5 h. Therefore, if the height of the whole cone is h, the height of the small cone is 3/5 of that. We need to find an expression for the height of the frustrum. Well, h stands for 1h, so 1h minus 3/5 h, 1 minus 3/5 is 2/5 h. And that's an expression for the height of the frustrum. So basically, guys, first things first, I saw our scale factor. It was in a fraction, so I turned it into a ratio. If the frustrum has a volume of 98 and the large cone has a volume of 125, therefore we can subtract those numbers to find the volume of the cone. So since the cone has a volume of 27, the small cone has a volume of 27, and the large cone has a volume of 125, we can find the scale factor by doing 125 divided by 27. Since it gave us a nasty number, we just wrote our scale factor as a fraction, 125 over 27. Then, since we're trying to find an expression for the height, we want to find the length scale factor. So if we know s cubed is 125 over 27, to find s, we're going to cube root both sides. So the cube root of 125 is 5, the cube root of 27 is 3, and that was our length scale factor. Now, since we knew the height of the big cone, we divided h by 5/3 to give us the height of the small cone. We divided the fractions, and that gave us 3/5 height, h. So the height of the small cone is 3/5 h, and the height of the big cone is 1h, and therefore the remainder must be the height of the frustrum, which is 2/5 h. Here are some questions you can try, all about similar shape involving length, area, and volume. So these are the first 4. These questions you should definitely know how to do 100%. And on the next page, there are some more challenging questions, definitely more like A to A star level problems. But give it all a try. Any questions, just let me know.